Hi everyone. Today we are going to Module 3 Subroutines and Control Abstraction. It contains the topic Static and Dynamic Link, Calling Sequence, Parameter Passing, Generic Subroutines and Modules, Exception Handling and Coroutine. So first we look what is abstraction. Abstraction is the act of representing essential features without including the background details of explanation. So we are representing only essential features without background details. Abstraction is a process by which the programmer can associate a name with a potentially complicated program fragment, which can then be thought of in terms of its purpose or function rather than in terms of its implementation. There are two types of abstraction: control abstraction and data abstraction. In control abstraction, the purpose of abstraction is to perform a well-defined operation. So in data representation abstraction, the purpose of abstraction is to represent some information. So we look what is subroutines. What do you mean by subroutines? Subroutines are the principal mechanism for control abstraction in most programming languages. Subprograms are the fundamental building blocks of programs and therefore among the most important concepts in programming language design. The reuse results in several different kinds of savings include memory space and coding time. So what is subroutine? Subroutines is a mechanism for control abstraction in programming languages. A subroutine performs its operation on behalf of a caller who waits for the subroutine to finish before continuing execution. Most subroutines are parameterized. The caller passes arguments that influence the subroutine's behavior or provide it with the data on which to operate. General subroutine characteristics are there. A subroutine has a single entry point. The caller is suspended during execution of the called subroutine, which implies that there is only one subroutine in execution at a given time. Then third one is control always return to the caller when the called subroutine execution terminates. A subprogram call is a request that the called subprogram being executed. A subprogram is said to be active if after having been called it has begun execution but has not yet completed that execution. There are two fundamental types of subroutines are there: procedures and functions. What is a procedure? A subroutine that does not return a value. What is a function? A subroutine that returns a value. Most subroutines are parameterized and arguments in the time of call are called actual parameters. They are mapped to the subroutine's formal parameters at the time a call occurs. Most languages require subroutines to be declared before they are used, though a few, including Fortran C and Lisp, do not. Declarations allow the compiler to verify that every call to a subroutine consistent with the declaration. For example, that it passes the right number and type of arguments. Subroutine header is the first line of the definition, serves several definitions. The following syntactic unit is a subroutine definition. The header provides a name for the subroutines, may optionally specify a list of parameters. Subroutine header examples: Fortran subroutine adder parameters. In adder it is shown as procedure adder parameters. In C it is shown as void adder parameters. Function declaration are common in C and C++ programs where they are called prototypes. Java and C# do not need declarations of their methods because there is no requirement that methods be defined because they are called in those languages. Then we look about what is stack layout for storage. The storage consumed by the parameters and the local variables can in most languages be allocated on a stack. The storage is allocated on a stack. The allocation of space on a subroutine call the stack is used. Each routine, as it is called, is given a new stack frame or activation record at the top of the stack. This frame may contains arguments and return address, bookkeeping information, including the return address and saved registers, local variables and temporaries. So, what are the contents of a stack frame? It contains arguments, return values, bookkeeping information, local variables and temporaries. When a subroutine returns, its frame is popped from the stack. This is the pictorial representation of stack layout for storage. Okay. So we can see the procedure C, in that D, procedure B, if then BLC, procedure A, B, main program A. That left side, that in right side it is shown the program. We assume that subroutine A has been called by the main program, and then it then calls subroutine B. Okay, then subroutine B subsequently calls C, which in turn calls D. At any given time, the stack pointer, that is represented by SP register, points to the first unused location on the stack or the last used location in some machines. And the frame pointer, that is represented by FP in the figure, register points to a known location within the frame of the current subroutine. Okay, this is a stack layout for storage. Stack recap: each routine as called get a new frame put on the top of the stack. It contains arguments, return values, bookkeeping information, local variables and temporaries. With the stack allocation, the subroutine frame for the current frame is on top of the stack. Here the figure we can see SP represents top of the stack, FP represents address within the top frame. To access non-local variables, static link or dynamic link are maintained in the frame. So, static and dynamic links maintained on stack. What is a dynamic link and what is static link? That is we are going to say. Dynamic links allow one to walk back the frame pointer linearly down the call stack. But static links allow one to walk back the frame pointer from a lexical viewpoint. Each stack frame contains a reference to the frame of the lexically surrounding subroutine. This reference is called static link. And these are all important topics that are asked in previous question papers. By analogy, the saved value of the frame pointer, which will be restored on subroutine return, is called dynamic link. So, what is static link? What is dynamic link? Each stack frame contains a reference to the frame of the lexically surrounding subroutine. This reference is static link, and the saved value of the frame pointer, which will be restored on a subroutine return, is called dynamic link. The static and dynamic link may or may not be the same depending on whether the current routine was called by its lexically surrounding routine or by some other routine nested in that surrounding routine. So in this figure we can see that static and dynamic link. So we can see within the left of the figure we can see within BCD all 5 routines are visible. Within A and E routines A, B, E are visible, but C and D are not. Given the calling sequence A, E, B, D, C, In that order, the frames will be allocated to the stack as shown in the right with the indicated static and dynamic link. So if subroutine D is called directly from B, then clearly B's frame will already on the stack. It is not visible in A or E because it is nested inside of B. A moment's thought may clear that it is only when control enters B, placing B's frame on the stack, and that D comes into view. It can therefore be called by C or by any other routine that is nested inside C or D, but only because they are also within B. So let's look what do you mean by subroutine frame or activation record. Activation record is used to store all related information for the execution of a subroutine. Before a subroutine is executed, the frame must be set up and some fields in the frame must be initialized. Formal arguments must be replaced with actual arguments. This is done in the calling sequence, a sequence of instruction before and after a subroutine to set up the frame. So what do you mean by calling sequence? Calling sequence is maintaining the subroutine call stack. Calling sequence in general have three components. The code executed by the caller immediately before and after subroutine call, and there are two terms, prologue and epilogue. Prologue means code executed in the beginning of the subroutine. Epilogue means code executed at the end of the subroutine. So we can see in the figure calling sequence code and call view and calling sequence code. So we can see the prologue, that is the beginning of the subroutine, and foo body epilogue code means that ending of subroutine. So this is all about subroutines and control abstraction in module 3. I will come with the next video. Till then, bye.